modeling division of fractions and also just dividing fractions in general. A couple of terms you're going to need to be familiar with real quick. Quotient. Quotient is simply the answer to a division problem, so since we're going to be doing some division, you'll need to know that term. A reciprocal. A reciprocal is when you flip a fraction over. Basically, the numerator becomes the denominator, and the denominator becomes the numerator. So for instance, down here in our examples, you can see I have 2/3. When you do the reciprocal of 2/3, you get 3/2. And then the second example down there is 1/2. When you do the reciprocal of 1/2, you get 2/1, or which we can also just call 2. We're going to be using those in this process today. Really quick, I just want to show you what a model of division of fractions looks like. This is the model of 3/4 divided by 1/2. Okay, 3/4 you can see is created by the three figures or the three squares within the large figure. The whole is what we would call it. So that would be 3 out of the 4s, or 3/4. Okay, divided in half. So basically, when we say divided by 1/2, they literally mean to divide what you have there in half. And you can see that we've split it. It used to have a line right there, which was right here. Okay, but that gets removed, because now what we have is 1 whole and then a half more. You can see they've just taken it and split it in half. So you literally end up with 1 1/2. All right, so we're going to take a look at drawing one of those on our own now. The model we're going to do is 7/3 divided by 1/3. So what we're going to do here is we're actually first going to modify 7/3 into a value that we know a little bit better about how to draw it out. 7/3 is a little bit different. We're going to actually make it its mixed number. If you've forgotten what a mixed number is, that's what you get when you divide the denominator into the numerator. Okay, to find the mixed number, we're going to divide 3 into 7. It doesn't go in evenly, but it does go in 2 times. 2 times 3 is 6. And what you have left over, 1, ends up becoming the numerator of your new mixed number fraction. So all of these values just kind of shift. The 3 and the 1 just kind of shift up. This becomes your whole number, and then you end up with 1/3. All right, so it ends up becoming 2 1/3. The reason why we want to work with that as far as models are concerned is because we want to see how many whole values we have. 7/3 is not a clear vision of that. And we're going to take 2 1/3 and we're actually going to divide it into thirds. All right, so in just a moment we'll get that set up. Let's go ahead and start with our 2. All right, so to model 2, what you will do is draw 2 bars. There's one. And I'll try to do one that's very similar in shape to that. There's a second one, very similar. All right, and then to model 1/3, you will do it very similar to the last model you saw when they did 3/4. You're going to make a figure, same shape, and you're going to break it into thirds. So to do that, I'll show you. You just draw lines. So we can draw them vertically or horizontally, but I'm going to draw them vertically here. All right, so notice I've broken it into third pieces. That's 2. Now to model the 2, we usually use shading here. So I'm going to shade in. I'll use yellow. All right, there's 1. There's 2. And then to model 1/3, you would just shade in 1 of the 3 bars. So that would be your 1. So now what they're asking us to do here is to actually take that model, 2 1/3, and to divide it into thirds. So to do that, we're going to do something very similar here. Let me do it in a different color. The first thing we're going to do is draw our first bar. Whoops, excuse me. Let me go back there. We're going to draw our first bar here. We can actually draw both of them. Let's draw our first and second bar. And we'll go ahead and draw the third one. We'll get them all drawn out. All right, and what we're going to do, since we're dividing into thirds, we're literally going to go and divide each of those figures into third pieces, like we did right up here. Okay, whoops, initially. Let me go back there. We did that with this initial model right here. That's dividing it into thirds. So we're going to go and do that with each of our figures at the bottom. So basically 2 vertical lines, we'll divide it into thirds. And we're dividing all of them into thirds this time. All right. We're dividing into thirds, and now we're going to count out how many thirds would be represented back up here. Okay, so basically you're taking your first model and you're just re-representing it now in thirds. So in other words, you're just showing it if we had divided it up into thirds. So I'm going to go ahead and shade everything that's shaded up at the top, right up here. So I'll do that again, and let's do that in green. So just like at the top, this whole first one was shaded in yellow, and we're going to shade it in green this time. And at the bottom, this one is also the second one. Again, we're just shading them because they were shaded up here at the top. So we're shading this one in as well. All right, and then on the third rectangle over here, that was already broken up into thirds, notice there was only one shaded. So again, you're only going to shade one of them. And to get your solution, you will actually count up how many thirds now have been shaded in. So as we count, we have 1, 2, 3, 4, 5, 6, 7. And that's actually going to be your answer, 7. So when you take 7 thirds and divide it by 1/3, you end up with the answer of 7. And that's just to show you in models. Now we're actually going to show you how to do that with the algorithm, mathematically I should say, on our next examples. So to divide the fractions, you can see down here at the bottom in red, this is a very key point here at the bottom that you need to remember. When you're dividing fractions, you must actually multiply by the second fraction's reciprocal. So in other words, I'll put that in terms as we work through this first example that hopefully you might understand. 3/10 divided by 1/2. This second fraction here needs to become its reciprocal in order to correctly do division of a fraction. So I'm going to set this problem up as 3/10, okay, divided by 1/2, and take you through the entire process. When you divide by fractions, we don't actually divide by a fraction. We actually multiply by the reciprocal. So you will always multiply. You will change the problem to multiplication, and you will actually multiply with that second fraction, and it's always that second fraction's reciprocal. So in this case, 1/2's reciprocal is going to become 2/1. So that becomes 3/10 times 2/1. Once you do that, you revert back to your multiplication of fractions element, which means you multiply straight across the top and straight across the bottom. Okay, so that's going to be 3 times 2, which gives you 6, and 10 times 1, which gives you 10. So in this case, because it says to write your answers in simplest form, you will need to simplify. 6 and 10 have a common value that can divide into them evenly, and that would be 2. 2 goes into 6 3 times, and 2 goes into 10 5 times. So your final answer for 3/10 divided by 1/2 would be 3/5. Now, if you didn't completely follow that, don't worry, we got a couple more examples to go along with this. So let's look at the next one. 4/5 divided by 3/8. All right, so just like the last example, we're going to look at our division sign, not just look at it, we're actually going to change it. That division sign will always become, when dealing with fractions, a multiplication sign. 4/5 times, then of course that second fraction will flip. You need to do the reciprocal, again called the reciprocal, which would become then 8/3. Once you do that, you are ready to multiply. So again, just keep in mind you multiply 4 times 8, 5 times 3. Straight across. There's no fancy stuff that has to be done here. 4 times 8 is 32. 5 times 3 is 15. Now again, depending on what your teacher is asking of you, you may need to modify this back into a mixed number. This is what we call improper, an improper fraction, and it's improper because the top number or numerator is larger than the denominator. So you'll need to go and probably modify that. So to modify that, which I showed you earlier, you divide the denominator into the numerator. 15 into 32. 15 goes into 32 how many times? It goes in 2 times. 2 times 15 is 30, and you're left with 2 left over. So the number on the division sign becomes your whole number. The remainder becomes your numerator, and what you divided by is your denominator. 2 and 2/15. Now both of these answers are the same. It's all dependent on whether or not your teacher's asking for you to make it a mixed number or keep it an improper fraction. In some cases, they may want you to keep it improper, so just keep that in mind. Let's take a look at a couple more. All right, this time we're going to do 1/5 divided by 2/3. By the time we get to the fourth example, I want you to try some on your own. So with this one, we're going to take 1/5. We're going to go ahead and modify that from a division to multiplication, change that up. And of course, we need to flip 2/3. 2/3 reciprocal, 3/2. Once you do that, you are ready to multiply straight across, straight across. So 1 times 3 is 3. 5 times 2 is 10. And keep in mind to always look at your final product here, or your final quotient, to make sure that you don't need to simplify. You may have to simplify. In this case, is there a number that goes evenly into 3 and 10? No. So you are finished at 3/10. All right, and then the last example then is going to be 5/9 divided by 3/4. But of course, we don't divide by fractions. We're going to multiply by the reciprocal. 3/4 reciprocal is 4/3. Okay, so at that point, we're ready to multiply straight across. 5 times 4 is 20. 9 times 3, 27. Just be careful with your multiplication because there can be some issues. You can do all this process correctly and not multiply right and get the problem wrong. So just because you know how to divide fractions, you need to be careful to make sure you're doing the basics correctly, which is multiplying. You end up with 20/27. Is there a number that goes into both 20 and 27? No. So your final quotient would be 20/27. Right, so let's take a look at some word problems. How will they modify these to word problems? Well, this is an example. How many 1/8 pound burgers can you make from a 1/2 pound of ground beef? Okay, what you have to do when you're doing a division of fractions problem like this in word problem is first identify that it is actually division. The way that you'll know that it's a division problem is because you are taking a whole or a total of something, in this case, a total of a 1/2 pound of ground beef, and you're trying to figure out how to divide it into 1/8 pieces, okay, or in this case, burgers. So our whole here is 1/2. That is our first value, because you're always dividing whatever the whole is. It may not actually be a whole, in this case it's actually a fraction, but your total of whatever you have, you're going to divide that up. So your setup would be 1/2 divided by 1/8. But as we've already learned, we know we can't actually divide that out. We need to multiply by the reciprocal. So that's going to be 1/2 times 8/1, which is the reciprocal of 1/8. And at that point, you're ready to multiply. 1 times 8 and 2 times 1. That's going to give you 8/2. That definitely can be simplified. This is actually 8 divided by 2. Keep in mind that fractions are division. When the numerator is larger than the denominator, it is a possibility that you actually are dealing with a whole number answer. And in this case, it is, because 2 goes into 8 evenly. How many times? 4. So that gives us an answer of 4 burgers that can be made in this scenario. Another example would be this obstacle course example. It says an obstacle course is 8/10 of a mile long. Each obstacle is placed every 1/5 of a mile along the course. So they want to know how many obstacles there will actually be in this race. Well, again, think to yourself, are we dealing with a whole that we're breaking up into pieces? Yes, because we have a 8/10 of a mile long track or course. That whole or total length of a course is being broken up into 1/5 pieces. So 8/10 of a mile course being broken up or divided into 1/5 pieces. So 8/10 divided by 1/5 would be your initial setup. But again, we won't divide that. We're going to multiply 8/10 by the reciprocal, which is 5/1. So multiplying straight across here, we'll get 40/10. And just like the last problem, you can see that this one actually is an improper fraction again, and it's going to divide unevenly. That is 40 over 10, or 40 divided by 10, which means you get a final answer of 4. So there will actually be 4 obstacles in this race. All right. And then the last example, a pitcher of water. Coach Pryor is 3/4 of a pitcher filled with water. He will fill each of the players' cups with 2/16 of water from the pitcher. How many cups will be added to each, or excuse me, how many cups will he add water to? So in other words, how many players will actually get water? Well, again, what is our total amount? What are we breaking up? In this case, we have a total of 3/4 of a pitcher. That is our total amount that we are dividing up into 2/16 pieces. Okay, and in this case, cups. So 3/4 divided by, or 3/4 divided by 2/16, we actually need to multiply by the reciprocal. All right, and in doing so, you're ready to multiply. 3 times 16, 4 times 2. If you don't know what 3 times 16 is, off to the side, you'll need to do a little scratch work. 6 times 3 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. So we end up with 48 over 8. All right, and again, you see you have an improper fraction. Look to see if this actually will divide out evenly before you go and try to modify it into a mixed number. Or you may want to anyway, because you'll find that in doing so that it actually does go out evenly, or comes out evenly. So 48 divided by 8 actually is 6. So he'll be able to fill 6 cups with that particular pitcher. All right. This has been Division of Fractions. Thank you for joining me.